Let's have a look at proving identities. You've done a lot of this in core maths and there isn't much difference here except you will be using reciprocals and the new square identities that you've learnt. Some quick tips, again, which you have learnt about in core maths. Don't forget left-hand side, right-hand side. Start with the more complicated side, or you can actually manipulate both sides simultaneously. Use the one side as a roadmap for simplifying the other side. So keep looking at the other side. If it asks you to end with a tan, then you don't have to go any further to a sine and a cos, for example. But sometimes it works out best to write all trig ratios in terms of sine and cosine. And that's when you are manipulating both sides, especially at the same time. If there are fractions, don't forget to get a lowest common denominator. Then factorize where possible. And use square identities where possible to simplify further. Don't forget about your conclusion of left-hand side and right-hand side. Okay, let's have a look at the following example. This one says, prove that your left-hand side is equal to your right-hand side. I've written out my left-hand side and right-hand side already. It's fine to start with the left-hand side and get your right-hand side. However, when I do an example, I always write both of them down, just in case I can do manipulation on the other side as well. So let's have a look at this example. I'm going to start with the left-hand side because there's a lot more going on there. I've got two fractions, tan, sec, and then I've got my cot on the right-hand side. So the first thing that stands out to me here is that I've got fractions. I'm not going to convert my tan theta to sine theta over cos theta because if you look at the right-hand side, there's a cot theta, which means that there's a good chance I won't even need to touch the sines and the cos. Okay, so first I'm going to find an LCD. I need to see sec theta minus 1 and sec theta plus 1 in my LCD. So I'm going to multiply this by my tan theta by sec theta plus 1 and this tan theta by sec theta minus 1 in order to get my LCD of sec theta minus 1 sec theta plus 1. Okay. Then I have a look at that. I can multiply out, so I'm going to multiply out here. Same thing there. In which case I get tan theta sec theta plus tan theta minus tan theta sec theta plus tan theta. Now don't forget about your denominator. If I multiply that out, I'm left with sec squared theta minus 1. I've multiplied out that what actually ends up being a difference of 2 squares. Now you should see that and that gives me 0. So I'm left with tan theta plus tan theta, which is 2 tan theta. Now remember, sec squared theta minus 1, that is a square identity. So my sec squared theta minus 1 lands up giving me tan squared theta. Don't forget about your square identity there and how we get that. That this becomes that according to our square identities. Okay, I can go one step further. That I've got 2 tan theta over tan squared theta. One of those cancels, so I've got 2 over tan theta. Now remembering that 1 over tan theta is cot theta, so this is 2 cot theta, which is my right-hand side, but I've written out my right-hand side already, so I end with therefore left-hand side equals right-hand side.